In this video, we're going to practice setting up some Newton's Law problems. So in this case, we've got this block right here, block 1, block 2, and you're pulling on block 2 at an angle of 30 degrees. So let's break up, we'll solve for block 1. Let's start by looking at these forces. We've got the normal force acting on block 1. We have the weight of block 1. And we have the frictional force of block 1 acting on block 2, which keeps block 2 from sitting there. Right? It's going to go. If we didn't have this frictional force right here, block 2 would fall off block 1. So if we write this down, we will get sum of forces in the x direction, would just be friction, block 1 on 2, which again is just N1 times mu equals M1 AX, because this one is accelerating. And then for the left side, it's not accelerating, that goes to 0, so we get 0 equals normal force being balanced by gravity. Let's look at the second block. So if we're looking at the second block, we have this force, I'm just going to call it a big F. We have N2, normal force on block 2. We have the weight of block 2. We have the weight of block 1 pushing on block 2, force pair with the normal force. And we have friction of block 2 acting on block 1. So this pairs with the frictional force acting on the other block. If we look at this, sum of forces in the x direction, we're going to get F adjacent side, so this is going to be cosine 30 plus, well, negative force of friction equals M2A. In the y direction, we're going to get N2 minus M1G minus M2G plus F sine, because we're looking at the opposite side, theta. In this case, theta was 30 degrees, and it's not accelerating, so that's 0. That's the setup for these two blocks. Let's try a different one. So now we have this block on a truck. So if we're looking, let's draw the forces acting on this block. Here's our block. What forces do we have? Well, we've got the normal force. We've got mass of the block times this. And if we didn't have friction, this block would just fly off. And you wouldn't be able, well, would fly off, wouldn't be able to cook anything. So you have friction pulling this way, which is just equal to mu times n. So when you set this up, you would get sum of forces in the x direction equals max. It's not 0 because it is accelerating, and we would just get mu n equals max. And for the y direction, you get sum of forces. Y direction equals may. This is 0, and this is just normal minus mg equals 0. Let's try one more example. So the final example we're going to talk about is a pulley. So one thing you have to deal with pulleys is you have to relate the acceleration of this block to this block. So if we look, you can see that this block moves 1 meter, but it takes 2 meters of rope to move this block 1 meter, because you have 1 meter here, 1 meter here. So if block 1 moves 2 meters per second, block 2 moves 1 meter per second. And thus we get A1 equals 2A block 2. So let's look at the forces on each individual block. If we're just looking at block 2, we've got tension, and we've got M2G. So sum of forces, in this case we only have the y direction, equals may, which in this case, this right here, call this block 2. This is 1 over half A1 M2 equals T plus T minus M2G. Alright, now let's set up block 1. So block 1, you only have tension pulling up, you have M1G, you get sum of forces, on block 1 equals M1A, and you get M1A equals tension minus M1G. And note that this tension right here is the same as all of these tensions, because tension in one rope is always going to be the same. This is a very important part whenever you deal with pulleys. So that's how to set up 3 problems. I hope this helps. Good luck. Let me know if you have any questions.